Hi students, I hope you understood in the previous class how to divide the polynomial p of x with the polynomial g of x. So now while dividing, if you obtain the remainder as 0, then g of x is a factor of p of x. If you get remainder 0, then g of x is a factor of p of x. So in the exercise 2.3, second question is asking verify whether the first polynomial is a factor of second polynomial or not. Verify whether the first polynomial is a factor of the second polynomial or not. That means verifying whether it is a factor or not. How do we say it is a factor? When after division, when we divide, if we obtain the remainder as 0, if you obtain the remainder as 0, then we say that it is a factor. So the exercise 2.3 second question, first bit, t square minus 3, 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12. This is the first polynomial and this is the second polynomial. So we are dividing the second polynomial with the first polynomial. If you get remainder 0, then the first one will be the factor of second one. See that yesterday in the class, previous class, I said that if the powers are not in order, then you have to make it as 0 into something, the term which is missing. Even without adding that 0 into the term, also we get the same answer. But I said it will be comfort for you to divide. Now today, without adding 0 into t, I'll explain how to do. Only the thing is you have to write the terms one below the other when you are subtracting exactly. See the first one, t square minus 3. So with this you are dividing. The second polynomial, that is 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12. First we have 2t to the power 4 and here we have t square. So to get t power 4, we require t square and the coefficient is 2 is there. So 2t square. With this multiply these two. 2t square, a rough work I am doing here. 2t square into t square minus 3. So 2 into t square, 2t square into t square, 2t to the power 4 minus 2 3s are 6t square. So right below the term where exactly t power 4 is there and where exactly t square is there. So 2t to the power 4 minus 6t square. Subtraction, minus, and this become plus. So these two get cancelled and bring down. This is nothing is there, so 3t square. It's nothing is there in the sense this is 0. Plus 3t cube minus 0 will give you 3t power 3. And here minus, this is plus. Minus 2 plus 6 will give you plus 4t square. And bring down the terms, both the terms at a time. That is minus 90, minus 90 and minus 12. Now you have 3t cube, that is plus sign. So right here plus and 3 is the coefficient. Here t power 3 and here t power 2. So we required 3t. So with 3t you are multiplying this divisor. 3t into t square, 3t cube, plus into minus, minus 3 3s are 9t. So under t cube you have to write t cube, under t you have to write t. So 3t cube and minus 9t. Then subtraction, minus, this will become plus. Now these two get cancelled. Here nothing is there, so it indicates as 0. 4t square, that sign is also plus, and these two get cancelled. One is plus 9, another is minus 9, and this is minus 12. Now we have the term 4t square, that is sign is plus, So plus 4, and here we have t square minus 3. So with 4 if you multiply t square minus 3, 4 into t square, that is 4t square, plus into minus, minus 4 3s are 12. This is minus, this is plus. Terms get cancelled. The remainder is 0. Therefore, if you get the remainder 0, then it is a factor. Which is a factor? The first polynomial is the factor of second polynomial. Therefore, t square minus 3 is a factor of 2 t to the power 4 plus 3 t cube minus 2 t square minus 9t minus 12. Therefore, statement is very important, because for each and every step marks will be there. So t square, first polynomial, is a factor of second polynomial. When do we write? When we obtain the remainder 0. Now question number 3. Obtain other zeros of 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. This is very important. When two zeros is given, we have to obtain the other two zeros. Now before obtaining zeros, you can guess how many zeros will be there for the given polynomial. This is p of x, that is a polynomial. So highest power, the degree of this given polynomial is, highest power is 4. So the degree also will be 4. So that biquadratic polynomial. What is that? Biquadratic polynomial. So if degree is 4, then zeros also will be 4. Already he gave 2 zeros. Then we have to obtain the other 2 zeros. So if it is 0 of the polynomial, yesterday in the previous class I said, if alpha is 0 of the polynomial, then x minus alpha is a factor. If beta is a factor, if beta is 0 of the polynomial, then x minus beta is a factor. So now, one is alpha, one is beta. Let solution. Let alpha is equals to root 5 by 3 and beta is equals to minus root 5 by 3. What I am saying, if alpha is a factor, then x minus alpha is, if alpha is 0, then x minus alpha is a factor. If beta is 0 of the polynomial, x minus beta is a factor. So here root 5 by 3 and minus root 5 by 3, alpha is equals to root 5 by 3 and beta is equals to minus root 5 by 3. If these are the zeros of given polynomial, then if these are the zeros of the given polynomial, then x minus alpha, what is alpha? X minus root 5 by 3 into, and x minus root 5 by 3 and x minus of minus root 5 by 3. Observe it. X minus alpha is a factor. X minus of minus are the factors. This step is very important. Alpha is equals to root 5 by 3 and beta is equals to minus 5 root 5 by 3 are the zeros of given polynomial. Then x minus root 5 by 3, because x minus alpha is a factor, x minus root 5 by 3 and x minus of minus root 5 by 3 are the factors. Here you see minus of minus, that means here x minus root 5 by 3 into factors. Factors means multipliers. These two factors. These are the two factors. Now x minus, this is one factor, this is another factor. So product of these two factors, what will give you? x minus root 5 by 3 into x minus into minus plus. So x plus root 5 by 3. Now you observe it. These are the two factors. These are the two factors. X minus root 5 by 3 into x plus root 5 by 3. Now we observe the pattern. A minus b into a plus b. What is the formula? A minus b into a plus b is a square minus b square. A minus b into a plus b will give you a square minus b square. That means x square minus root 5 by 3 whole square. X square minus root 5 by 3 whole square. Here square and square get cancelled. We will get x square minus 5 by 3. That means these are the zeros. Then which are the zeros? Root 5 by 3 and minus root 5 by 3. We obtain x square minus 5 by 3. Now this is a factor of the given polynomial. So therefore x square minus 5 by 3 is a factor of given polynomial. X square minus 5 by 3 is a factor of given polynomial. Now with this factor, if you divide the given polynomial, with this factor, if you divide this polynomial, you get a quotient. From the quotient, then we have to obtain the other two zeros. If you divide with this, because this is a factor, the given polynomial 3x power 4 plus 6x cube minus 2x square minus 10x minus 5, then you obtain a quotient which you get. That quotient, if you, from the quotient, we will obtain the other two zeros. So from the zeros, we got the factor as x square minus 5 by 3. Now, we are dividing this factor x square minus 5 by 3. With this, we are dividing the given polynomial with the factor. Observe it. Now the factor means we have to obtain the remainder 0. This is a factor x square minus 5 by 3 to the given polynomial. So on dividing, we are getting the quotient, that is another factor. From the factor, we obtain the other two zeros. The first one x square minus 5 by 3, and here we have 3x to the power 4. 3x to the power 4, observe it carefully. 3 is their coefficient and x power 4 is the degree, that is highest power. So to obtain 3x power 4, this we are multiplying. If you divide this and this, then you get the quotient as 3x square. You get the quotient as 3x square. Here, for the first step I am talking. So now multiply this into the first this divisor. Here rough work I am doing here, 3x square into x to the power 2 by 5 by 3. Observe it carefully. Here rough work I am doing. 3x square into x square, that is 3x to the power 4 plus into minus 3x square into 5 by 3. Observe it, this is a fraction. 3x square into 5, you will be obtaining 15. Clearly you see this, 3x square into 5 by 3. So 3x square into 5 by 3, 3 gets cancelled. You have 5 into x square, that is 5x square. 3x to the power 4 minus 5x square. So here under x power 4 you have to write x power 4. Under x square term you write x square term. So 3x to the power 4, then minus 5x square, subtraction minus, this becomes plus. These two cancel, and here you have 0. The nothing is there in the down, that is 0. Then plus first term 6x cube, no need to write plus, 6x cube, and this is plus 5 and this is minus 2. So plus 3x square, and bring down the terms, that is minus 10x and minus 5. Now the first place you have 6x cube, and here you have x square. So 6x cube, if you divide with x square, I am talking the first term, 6x cube if you divide with x square, then the quotient will be, here 6 is there, here x cube. So quotient will be minus 6x. So with, sorry, the sign is plus. I'm very sorry. Here plus sign is there, so plus 6x. So with 6x, you have to multiply x square minus 5 by 3. Now if you multiply 6x into x square will give you 6x cube. 6x into x square will give you 6x cube. Then plus into minus, minus 6x into 5 by 3 will give you 3 ones are 3 twos are, so 6x cube minus 2x into 5, that is 10x. 3 twos are, if you cancel, 2 into 5, 10x. So here under 6x cube you write 6x cube, under 6x cube write 6x cube minus 10x. So under 10x you write 10x. Then subtraction, this is minus and this become plus. So these two gets cancelled because both plus and minus, here also minus and plus gets cancelled. You have 3x square and minus 5. 3x square minus 5. Now here the coefficient 3 is there. Here you have term as x square. Here also x square. So 3x square and x square. Then the here plus sign, that is 3. So with 3 if you multiply x square, 3 into x square minus 5 by 3. A 3 into x square will give you 3x square plus into minus. Minus 3 into 3 gets cancelled. The remainder, that is 3 if you get cancelled, 5 will be left over. 3 into 5 by 3 gets cancelled, 5 is left over. So 3x square minus 5. Now subtraction, minus and plus. So these two gets cancelled, minus and plus get cancelled. So remainder we obtained 0. Already we said it is a factor, that means remainder is 0. Now this is another factor of the given polynomial. Which is another factor? 3x square plus 6x plus 3 is the other factor of given polynomial. See, the power is 4. That means we need to obtain 4 zeros. Already 2 zeros he gave in the question. One is root 5 by 3, another is minus root 5 by 3. Now we got the quotient. This is the quotient what exactly we got. 3x square plus 6x plus 3. Now from this quotient, from this you have to obtain the other 2 zeros. How to obtain the other 2 zeros when we get quadratic polynomial? By splitting the middle term. So if you split this middle term, but if you factorize this, then you will be obtaining the other 2 zeros. Now we have to factorize 3x square plus 6x plus 3. That 3x square plus 6x plus 3 we got from when we divide with x square minus 5 by 3 the given polynomial. This is the quotient. So now we are factorizing. That is, if you factorize 3x square plus 6x plus 3. Before factorizing, everyone knows how to factorize this, that by multiplying the ax square, that is the first term and the constant, that is refer here, 3x square into 3 will give you 9x square. For 9x square find out the factors. You have to find out the factors for 9x square, or for the 9 factors are 1 and 9, 3 and 3. These are the 2 factors. You have to find out, you have to write the pairs of factors which gives 9 as the product. Now write besides that 1x, 9x, 3x, 3x. Either by adding or subtracting. These factors, the pair of factors should give the middle term either by adding or subtracting. Either the sum or the difference should be equal to the middle term. So which pair is suitable? This pair is suitable, 3x and 3x, because 3 into 3, 3 3s are 9, x into x square, 3x plus 3x will give you 6x square. So that is 3x square plus 3x plus 3x plus 3. Now in these two, both are the multiples of 3. So we can take out 3x common. We are taking out 3x common. So 3x if you take out common, then x plus 1. Now in these two, if you take out, which is possibility to take out common? 3. That is plus 3 if you take out common, plus 3 if you take out common, then x plus 1. Now in both the places, x plus 1 and x plus 1 is common. So x plus 1 into 3x plus 3. The leftover terms. If you take out x plus 1 common, 3x plus 3. Now as we are finding zeros, as we are finding zeros, this is the rough work actually what we did here. As we are finding zeros, now x plus 1 is equal to 0, then x is equals to, transpose this side, it will be minus 1. X plus 1 is equals to 0, then x is equals to minus 1. Now here another factor, this is 3x plus 3 is equals to 0, then 3x is equals to, transpose plus 3 this side, that will be minus 3, transposing. Now transpose 3 this side, I am writing over here. Here I am writing, if you transpose 3 this side, x is equals to minus 3 by 3, which will give you here also 3 ones are cancel. So 3 ones are cancel, minus 1 is left over, x is equals to minus 1. That means we obtain the other two zeros are minus 1 and minus 1. Therefore other two zeros are, what are those? Minus 1 and minus 1. Because the power of the highest power, that is the degree of the given polynomial, is 4. So we obtained more two zeros. He gave other two zeros. Then we obtained more two zeros. This is how we have to find when they give two zeros and the rest other two zeros for a biquadratic polynomial. Very, very important question. I hope you understood. Now question number 4. On dividing x cube minus 3x square plus x plus 2 by polynomial g of x, the quotient and the remainder were x minus 2 and minus 2x plus 4 respectively. Find g of x. So he gave the p of x is given and q of x, that is quotient, is given, and r of x, a remainder, is also given. We have to find g of x. What is g of x? That is the divisor. We have to find the divisor. So we know the rule, general rule. Before start the solution, the general rule is what? Dividend is equals to divisor into quotient plus remainder. Divisor into quotient plus remainder is equals to dividend. So that is divisor into quotient plus these two are in the product form, remainder is equals to dividend. Divisor into quotient divisor into quotient plus remainder is equals to dividend. Divisor into quotient plus remainder is equals to dividend. So what is divisor? That is g of x. G of x into quotient. Here quotient and the remainder. So quotient is x minus 2. X minus 2 plus, this is one term, it plus, the remainder is minus 2x plus 4. This is the remainder, which should be equal to the polynomial p of x. That is, p of x is nothing but x cube x cube minus 3x square plus x plus 2. Now next step, g of x into x minus 2 is equals to plus value, transpose that side. We are subtracting the remainder from the dividend. We are subtracting remainder from the dividend. So transpose that side. When you transpose that side, the sign of this plus. When you transpose this side, the signs will be changed. That is, first you write this x cube minus 3x square plus x plus 2. X cube minus 3x square plus x plus 2. Now when you transpose this side, here you see plus into minus, minus 2x is there. When you transpose it will become plus 2x, and plus into plus, plus 4 is there. When you transpose this side, it will be minus 4. Now x cube minus 3x square, observe it, this is 1x plus 2x, 1x plus 2x, 3x, together is 3x. So plus 3x, then this is plus 2 and this is minus 4. Plus 2 minus 4 will give you minus 2. Plus 2 minus 4 will give you minus 2. Now this side you have g of x into x minus 2 is equals to this one. Divisor, here you see g of x is what? Divisor, into the quotient is equals to, we subtracted the remainder, then we obtain this value. Now if we transpose x minus 2, it will divide, then we obtain the g of x, that is divisor. So we have to divide now x power 3 minus 3x square plus 3x minus 2 with x minus 2. So g of x into x minus 2 is equals to x cube minus 3x square plus 3x minus 2. Now transpose this side, then g of x is equals to x minus 2, we are transposing towards this side. The operation between these two is multiplication. When you transpose this side, then it divides. So x minus 2, when you transpose this side, it divides. So g of x is equals to x cube minus 3x square plus 3x minus 2 by x minus 2. That means now we are going to divide on dividing. So divide, now this we are dividing on dividing this x cube minus 3x square plus 3x minus 2 by x minus 2. So with x minus 2 we are dividing this. So x minus 2 will be outside and that is a divisor. Here now at present x minus 2 is a divisor. So x minus 2, next, now x cube minus 3x square plus 3x minus 2. X cube minus 3x square plus 3x minus 2, and this is x minus 2. Now here you have x cube and x. To get the, when you divide x cube with x, you obtain here x square. So with x square you have to multiply these two, doing rough work over here. X square into x minus 2. X square into x minus 2. X square into x. X cube minus x square into 2. 2x square. So here x cube minus 2x square. Now when you subtract, signs will change, minus and plus, these two get cancelled. This is minus 3x square and this is plus 2x square. Minus 3 plus 2 will give you, that is 1x square. That what sign you have to write? Minus 3 plus 2 minus 1x square. And bring down the terms, plus 3x minus 2. Plus 3x minus 2. Now here you have the sign minus, and here the first term is x square and here you have x. So on dividing x square with x, you obtain here x. So x square, this is minus, so we are writing minus. So with minus x, including the sign you have to take. So with minus x you are multiplying x minus 2. Minus into plus, minus x square, minus into minus, plus x into 2, that is 2x. So minus x square plus minus x square plus 2x. Subtraction, this becomes plus minus. These two cancel and here plus 3x minus 2x. Plus 3x minus 2x will give you x, and bring down this minus 2. Observe it, x minus 2 is there and x minus 2 is there. We required x and x. On dividing x, we get 1. So it has plus sign, so plus 1. So with 1 if you multiply x minus 2, you obtain the same term x minus 2, which will give you the remainder here. Change the sign, minus, plus, remainder we obtained 0. Therefore, what he asked actually in the question, he asked on dividing some polynomial p of x, obtain the quotient and the remainder, find g of x. He asked to find g of x. So with the result, here what we got here as a quotient in this, that is the g of x. This value is the g of x. So therefore g of x is equals to, x square minus x plus 1. This is the value g of x. So with this, when they divide the given polynomial, then they obtained the remainder and the quotient what he gave in the question exactly. This is how we have to do. When they give remainder, quotient and dividend, to obtain the divisor, this is the procedure. I hope you understood how to divide p of x with g of x, and how to obtain the remainder, and how to identify the other two zeros when they give two zeros, and here are, and how to find out the given term is a factor or not. When do we say it is a factor? If the remainder is 0 after dividing, while dividing or on dividing, when we obtain remainder 0, then the divisor will be the factor of dividend. That means g of x will be the factor of p of x. So now homework, here are some homework questions from exercise 2.3. Question number 2. Check whether the first polynomial is a factor of second polynomial by dividing the second polynomial by the first polynomial. So which is the first polynomial? This is the first polynomial and this is second polynomial. So this is g of x and this is p of x. So this will be, with this you are dividing this, long division method. And if you get remainder 0, then the first one will be the factor. Similarly the second one, you have to divide this by this. So this is the divisor and this is the dividend. That means this is g of x and this is p of x. G of x, p of x. Now question number 5. Give examples of polynomials p of x, g of x, q of x and r of x. That means polynomial dividend you have to give. Dividend, divisor, quotient and the remainder. You have to make your own example which satisfies the division algorithm. Where the condition is how it should be satisfy the division algorithm, but the condition should be, first one, degree of p of x should be equal to degree of q of x. Degree means highest power in the variable. So degree of p of x should be equal to degree of q of x. And degree of q of x should be the second condition. Degree of q of x, this is second question in the condition. Second question, that condition is this: degree of q of x is equals to degree of r of x, remainder and the quotient. Then third one, degree of r of x means remainder you have to obtain as 0. A degree of r of x. remainder, degree of r of x is equals, not remainder, degree of r of x should be 0. Degree of r of x should be 0. That means in the remainder you should not get any like variable. So now this is the condition, these are the conditions for the first question is separate, second question separate, third question separate. But you make your own examples. You can make own examples. N number of examples. The answer may vary from one person to the other person. The one person to the other person. However you want. But the condition should satisfy degree of P of x should be degree of Q of x in the first question. In the second question, degree of Q of x should be equal to degree of R of x. And the third question is degree of R of x must be 0. That it should satisfy even division algorithm also. What is division algorithm? Dividend is equals to divisor into quotient plus remainder. It has to satisfy the division algorithm. In such a way, you have to give your own examples. So with this, the chapter polynomial is completed. All the best. I hope you understood the chapter.